Hello and welcome to part 2 of our third lesson in Unit 0 in our grade 10 academic math class. This is solving polynomial equations. The first part we worked through, or I talked through a worked example, and then we went through a formal check to prove that our final answer of y equals 11/5 did indeed make the left side of the equation equal to the right side. Let's work through a couple more examples. I think outside of the expansion and making sure that we keep our signs straight when we're working with equations, or rather expressions like this, or equations, I guess, is to handle ones that have fractions. So let's start with B. What we have here is 5 over 3 times x minus 1 equals 3x over 2. So again, we're trying to solve for x. First thing I want to point out, and you don't have to write this part down, but the first thing I want to point out is that 5 over 3 times x minus 1 as an entity could also be written as x minus 1 over 1. And if we were to actually expand this fraction, or multiply this fraction out, 5 times this and 3 times 1, you'd actually end up with 5x minus 1 all over 3. That's my preferred method for writing a question like this. It just helps me sort of recognize that the 5 times x minus 1 numerator has 3 and only 3 as a denominator. So that's how I'm going to rewrite it anytime they show up like that in homework questions. If this particular formatting doesn't bother you, then you don't have to do this step, but I think it makes it easier, especially if you're not 100% confident with what you're doing. So I'm going to rewrite that as 5, as I said, x minus 1, put that whole thing over 3 equals 3x over 2. Now I would hazard a guess that most people don't particularly like fractions. I can take or leave fractions, I don't mind them myself, but a strategy for moving forward in a question like this is recognizing what is a common denominator between the two denominators that we have, 3 and 2. So the lowest common denominator that we can use is going to be 6. So what I'm going to recommend is taking that piece of information. We're not actually going for a common denominator here. What we're doing is finding the value of that common denominator, and then we're going to multiply each term by it. And I want to make sure that we note that. Times 6, but it has to be each term. This is important because sometimes there's a term sort of hidden in there, and you should know exactly how many terms you have before you start multiplying by 6. So in this case, this is a single term, this is a single term, and we are going to multiply each of these by 6. Again, I'm keeping it as a 6 over 1, just so visually it's a little bit easier to see what's going on. As we move to this next step, as always, we're going to do some reducing if we can, and this is where the magic of this strategy really comes in. So if I look at this first term, I recognize that I can divide both numerator and denominator by 3. Dividing 3 by 3 gives me 1. Dividing 6 by 3, divide by 3 gives me a 2. So if I were going to then rewrite this first line, I would have 2 times 5 times x minus 1. You'll notice that by selecting a common denominator, but then multiplying the entire term by it, we've effectively removed the fractionness of it, for lack of a better word. Which I think for a lot of students, not having the fractions as part of the solution will be really quite helpful. Let's move on to the second half. So in the second half, same thing. Let's see if there's some reducing we can do here. I recognize there is. I can reduce both top and bottom by 2. So I'm dividing the numerator by, or the denominator by 2. 2 divided by 2 gives me 1, and 6 divided by 2 gives me 3. So if I were now to rewrite this numerator, I would have 3x times the 3 that's just hanging around there. And again, you'll notice our denominator is 1, so effectively the denominator has been removed from the equation as being something that might cause you confusion or trouble. So now let's expand, or let's multiply these out. So we have 2 times 5, that's going to give us 10. We have x minus 1, and here we have 3x times 3, that's going to give us 9x. We'll continue. We're going to distribute this 10 into each of these two terms in the binomial. So 10 times x is 10x, and 10 times negative 1 is negative 10. There's our 9x. So as before here, our goal is to get all of the variable terms on one side and all of the constant terms onto the other. So I'm a variable term on the left kind of guy and a constant term on the right. Strictly speaking, there's absolutely nothing wrong with doing it the other way around if it makes more mathematical sense. In this case, I don't think it's a whole lot one way or the other. So what I'm going to do is I'm going to transpose 9x to the other side of the equation, and I'm going to do that by subtracting 9x from both sides, because on the right side of the equation we were adding 9x. But I need to be able to keep this equal, so I'm going to subtract 9x from both sides. At the same time, I'm going to take this negative 10x and I'm going to transpose it to the other side of the equation. How do I undo minus 10? Well, I will be adding 10 to both sides. So let's sort that out in our next step. We have 10x minus 9x. I'll write that out. Although if you can keep it all in your head, that's fine too. And on the right side, after we had transposed the 9x, we would have had 0 plus 10. That's the transposed negative 10. And now we simplify. 10x minus 9x is 1x, or x. And on the right side, we have 10. And that is a solved linear equation with fractions and how to sort of clear them out. Hopefully that made sense. Again, I'm going to stress that when you're working in the notes, you really copy down a good version of what I've written here. Don't just watch it and kind of assume that you're going to remember it. It can be complicated, it can be confusing. It's certainly a lot easier when I'm talking through it and I know what to do next. And you can rely on that. When you're looking at the questions like this on your own, sometimes it makes it more difficult. So take the time in your notes or in your notebook to include a question like this as a reference for when you start working through the homework. All right, let's look at this one here. This one, similar to the other one, or B, in that we have two fractions, but I'm going to show you another strategy now. Instead of finding just a common denominator, I'm going to show you a strategy that will work if you have a single term on the left side of the equation, which we do. It's got a complicated numerator, but it's still a single term, and then a single term on the right side. Again, complicated numerator, but a single term. So what we can do, and I've sort of written it over here, so I'll zoom out a little bit so you can see it. What I've indicated you can do is you can cross multiply. Now this is a strategy you should be bringing forward from grade 9. Essentially what it means is you're multiplying the numerator of the first term by the denominator of the second, and the denominator of the first term by the numerator of the second. Now what does that do? Essentially what it does is it just shortcuts this step where we would look, say, on the version on the right. What I'd be looking for is what's a common denominator between 3 and 8. There's nothing really obvious, so if I multiply 3 and 8 together, I'm going to get 24. So if I were to multiply both of these sides here by 24, times 24, and times 24, the first thing I would encourage you to do is do some reducing, which you would then recognize 3 divides into itself once and into that 8 times, and 8 divides into itself once and into 24 3 times. So what you'll notice we would have left is 8 times 2x minus 5 and 3 times x plus 3, which if you look over here is exactly what we're going to have left if we cross multiply. I would have 8 times 2x minus 5 equals 3 times x plus 3. So I'm just shortcutting this step here where we decide what the common denominator is, multiply it out, and off we go. Could we have used this method over in question B? Absolutely. I just want to make sure you get a chance to have some choices and use whatever one makes the most sense to you. To me, this is the one that's the fastest and may provide the fewer opportunities for making errors. So let's get to the expansion. Here we are going to expand. We're going to start by multiplying 8 by the first term, 8 by the second term, followed by 3 by the first term, and 3 by the second term. So let's do that math. 8 times 2x is 16x, and 8 times negative 5 is negative 40. Equals 3 times x, which is 3x, and 3 times 3, which is 9. All right, we're looking great here. From here, we're just going to start transposing terms. Again, I'm going to get all of my variable terms onto the left side. I'm going to do that by subtracting 3x from both sides. And I'm going to transpose the negative 40 over to the other side by adding 40 to both sides, plus 40. So I'm going to do the step in my head this time. If I have 16x minus 3x, that's going to give me 13x's. And if I have 9 plus 40, that's going to give me 49. So now we're at a place where we have 13x equals 49. We have an isolated variable term, but we don't actually have the variable isolated yet. We do that by recognizing 13 is being multiplied by x. I undo that by dividing both sides by 13. And x will then equal 49/13. We should see if that's going to be reduced. And it can't be reduced because 13 is a prime number, and 49 only has 1, 7, and 49 as factors. So there's no common factor that's available to both the numerator and the denominator. So that is the end of that particular piece. Let's do one more here right at the bottom just to get us going. this is one where we're going to do some substitution first and then work it through. So we have given formula A equals BH over 2. We're going to isolate B and then solve for B by substituting A and H in. So actually this video is getting a bit long. Let's take this in part number 3. So we'll see you in part number 3 and then you can get to the homework.